everybody. I would like to welcome you all to another session of the AIIM webinar that we are holding as part of SolutionBuggy's knowledge sharing session. So this is the sixth webinar as part of AIIM 2024. For all of those who are wondering, AIIM stands for Accelerating Innovation and Ideas in Manufacturing. And today's session is going to be on biogas, CBG, and biomass and its potential in the energy sector. We will basically look at what the industry in general holds, what are the current market trends, and what is the potential for growth, and also what is the government, helping in terms of the SATAT scheme, or it could be in terms of the Govardhan scheme and things like that, for faster adoption of CBG. And CBG has got so much of PR over the last 6 to 8 months. We have also been getting so many inquiries, and entrepreneurs are generally interested to get into this sector. But there are a lot of pros and cons as well, which Shashiji will be discussing. And we will be looking at each of these aspects so that the entrepreneur can make an informed decision. Before I start, a quick introduction to SolutionBuggy. I think most of you are already familiar. We are an online platform to connect manufacturing industries with the experts. Today, we have one of India's largest platform for the MSME sector, especially in the manufacturing sector, where we have about 12,000 plus experts, and we have done about 3,500 projects over the last 6 years. And when I say projects, it is anything from lean consulting to training programs to all the way to setting up of industries, right from an ideation stage to commercialization stage, where we take care of entire basic market research, product identification, new product development, detailed project report, machinery procurement, plant setup, commissioning, supply chain management, technology transfer from foreign countries, sales and marketing, and development of new markets as well. I would like to introduce myself, Guru Prasad Bangle, Director at SolutionBuggy. I have about 20 plus years of experience in consulting. I am an electronics engineer and an MBA from IIM Bangalore. This is my second startup. I basically look after projects at SolutionBuggy. And coming to today's speaker, over the next 90 minutes, he's going to elaborate on the entire topic of bio-CBG. You might have already seen him on various CBG platforms and also programs from academic institutes as well, wherein he has been a speaker. This institute, HiCons, has been a pioneer, I can say, working on CBG plant setups. They have almost, they've been in the sector for the last 4+ years and have done phenomenal, I would say phenomenally well in not only just setting up the plants, but also giving knowledge to the people. Today, what is happening is CBG being a hot sector, anybody and everybody is claiming to have the right expertise. But we need to understand that it is not just machinery which is going to do the trick. A lot of it depends upon, because it is basically a biological, reaction that needs to happen. So a lot of it depends on what the microorganism is going to eat, what kind of grass or waste it is going to feed upon, and based on that, what is the kind of methane that is going to come out, and what is the efficiency of your plant. See, anybody can set up a machinery, but it needs to be tuned to the right efficiency, and you should have the right raw materials. So that is where his company is, fighting tooth and nail and giving the right knowledge to the people. So I welcome you, Mr. Shashi Hegde. I think you are on mute.
Thank you, Guru Prasad ji, for organizing this good event with a lot of enthusiastic participation. What we should aim today is one is the learning part. The other is people who have learnt a bit of about it or gone through the Google search or interacted. I welcome all of them to pose the question through you so that it can be answered. And by end of the session, let us all target that we should be either on a yes side or no side. There should not be any gray areas left.
Right.
So that's what I will aim.
So we will share the PPT.
I think I will share the screen. I have the PPTs.
You have the
so that it will be more convenient for the flow. And while I'm sharing, I may not be able to see what is happening on the what you call Zoom screen.
The questions we will take care. Whichever we are not able to answer, I will put it across to you at the right time.
Sure, sir. So since this is not particularly my marketing event, I would not get into too much of dwelling into icons, but I would say we focus majorly on agri-biomass based projects, especially on the Napier. Why that Napier? Those things we'll figure out while we are talking about the feedstock. Now, for the benefit of the people who are very new to the sector, we will get on to the market economics or how it is looking.
Right.
Currently, the India is consuming about $101 to $105 billion of oil and gas. That is all our petrol, diesel, natural gas, everything together. In that, 9 billion is the natural gas. Predominantly, it comes from in the form of LNG, which is liquefied natural gas. Just like we South Indians make various dosa out of one single batter, natural gas, PNG, CNG, LNG, everything is same, only the form factor is different. Then we have this sector is growing at 7.5, 7.2% CAGR, and this was the forecast done by PPAC, that is Petroleum Planning and Analysis Cell, and that forecast is holding very good, just like a good astrologer. So since last 5 to 6 years, their forecast and the real growth is matching that. And currently, the whole of this 9 billion, which of this 101 or 105, it is about 6% of our energy basket. The electricity, that this whatever we are using in all the electricity, all the basket, if you put across, it is 6%. And the government of India wants to make this gas-based economy at least 15%, because there are many advantages, especially the solution or the pollution side of it. To become 15%, 6% has to become 15%. That will become 3x increase. Why 3x is there will be a natural growth of the 7.2% also. So there will be consumption growth and in the whole of the energy. So to meet 15%, we need 3x. And there is a 5% blending obligation, just like it is happening in ethanol. Compressed biogas, this also has to be blended in the natural gas pipeline or in the retail outlet or whatever way. So that itself need about 1,000 projects to come up in India. And as we all know, 80% of our oil is imported and 50 to 55% of natural gas is imported. There is a other angle which is saving the dollars going out. The India is spending quite a lot, most of like 13 to 14% of its budget on buying the energy or oil and gas. So this 13-14%, if we save, it will go into our own development and infrastructure. So that's why government wants to reduce that import part of it. So this is the size of the market. Now what I request is I will go to the feedstock side. So what kind of feedstock, what gets used? Uh, I assume that most of you are knowing that this is a waste to energy project. We are going to biodegrade the waste and make it a methane gas. So that is the uh, basic understanding. Now, while selection of the feedstock, there are many things. There is agricultural residue, animal waste, municipal solid waste, freshly grown things like napier grass, miscanthus, water hyacinth, so many things. Then there is a sugar factory that supply chain. If you look up, there is a Pressmud. Biogas is there. So many things are there. As the entrepreneurs or while technically selecting, we need not get into the depth of a technology provider, but it is always advantageous to know the things so that people will not misguide you. That is the idea. So first rule I would like to teach you today is any gas CH4, that is the methane, will finally come from something called glucose. If you put a packet of glucon D, there will not be any fertilizer. The entire glucon D will become a CH4, that is the methane gas. Whereas this, there will be glucose will not be directly available in the nature. So there will be multiple type of glucose, sucrose, everything will be joined together, which we call it as sugar. So sugar, if it has to become a gas, sugar has to be broken. We have to make it glucose and make it a methane. And multiple sugar, there are 18 types of sugars. Those will generally put together, join together, called carbohydrate. Something like our rice is majorly carbohydrate, what we know. So carbohydrate, if we are feeding, it has to become sugar, then glucose, then CH4. Then carbohydrate and fatty acids, if you add, that is called protein. So protein has to be broken to this. Multiple proteins, all these put together, it becomes fat. So that way, even if we consume a lot of oil, we have a digestion problem. Similar way, the food chain is fixed. So whatever energy or gas getting consumed, produced, it is from glucose. So that is the rule number one. So there is nothing called Napier grass, MSW at all. It is all about in this how much of material we are able to convert it to glucose so that it will become a methane. That is the rule number one which you have to understand. Now how it is practically meaningful to us is sun is the source of energy for everything, and primarily there is plant which grows. There is no human, animal, nothing will grow just because of the sun. But plants are taking the energy directly, which is the primary thing. That's why we use napier grass. Then these plants are eaten by animals or human or whatever. Then what happens? Either they will consume this energy or they will accumulate the energy. So all our obesity is coming because of the accumulation of it. So now we have a huge gas potential in these two stages. If you put the primarily the grass or the agricultural biomass, or if you put the slaughterhouse waste kind of thing, there is a huge amount of energy. Then there is all this animal after digesting, they are doing excretion, that is cow dung, poultry litter, pig manure, night soil, which is from human, to all those things, including Pressmud. Any raw material which has passed through an animal or machine, that would have lost maximum part of its energy potential. So the longer you go in the chain, lesser the gas you will get it. That is the first rule. You take any biomass, any raw material, pass it through this filter, you will know which is better and which is not better. Then coming to weight, we hear that a lot of plants are 100-ton CBG plant, 500-ton CBG plant. For us, it does not make any Meaning, the reason is our money is going to come from the output from the plant. Input, you can put anything. You can even put the soil, which will become a weight, but the gas will not come out. So there are various things. Let us say our coconut husk, coconut shell, the bones, or the coir, sand, mud, all those things are completely non-digestible. So they will not produce any gas. So always talk to your technology provider, whoever it is, in terms of output. And within this whole thing, what we are putting, all these multiple feedstocks, just you divide like how much is digestible and how much is going to be a leftover. And within digestible, sugar is there, carbohydrate, protein is there, cellulose, hemicellulose is the plant fiber. So most of the people can digest these things, sugar, carbohydrate, and protein. If we mix the chapati atta and keep it in the outside air, within 2-3 days, it will start rotting. It will start the process of hydrolysis. Then it will become sour or katta ho jata hai. So those things will start naturally. The fibrous part, which is like paddy straw, grass, all those things will not get rotten within a month or 6 month time. So this is digestible, but for digesting these fibers, plant fibers, there is additional process involvement is required. Otherwise, cellulose and hemicellulose also is actually made of sugar only. So these are the ways the gas will come out. So this is rule number 2. What is digestible and what is not digestible, and not digestible will never produce any gas, even though we are feeding into the digester. Then coming to agri residue, we come across a lot of news about the paddy straw, stubble burning, wheat straw, bagasse, so many things. What we have to understand is from paddy around 80 to 90 kg per ton of CBG is practically coming today, even though its potentially is probably more than 140 kgs per ton. Practically, this is the number. In this, what we have to understand is this paddy kernels are attached to something called spikelet. This spikelet is completely of lignin. To give the example, coconut coir mat, even if we throw it outside in the rainy season also, 3-4 years it will not become digestible. It will not digest at all. So even within the nature also, we have very limited kind of microorganisms which can destroy the lignin part. So all these spikelets are lignin. So when people harvest with combined harvester, they are going to harvest top portion of the paddy straw only. So top portion is more or less made of this spikelet thing. There is less digestible biomass, whereas the whole lot of gas potential is hiding in these things. Stem part. So here, even though we have agri biomass collection, whatever is available, it is important to collect from the field. This leftover below this spikelet, whatever is left over, we have to collect that. Then only it becomes meaningful. Even if you put hundreds of tons of the top portion, it may not give you good yield. That is the thing. Then coming to the wheat straw, that is also of the same story. So whatever this spike is there, that is not digestible that easily. Better to make a pellet out of it. Then coming to our maize. So maize there are two options. One is the maize silage, which is there, and there is a cobs. Option 3 is harvesting it halfway through when just milk gets formed in the corn kernels and digest at that time. So that then you will not get the corn at all. You will be using this as an entire energy crop, just like Europeans. The same thing we slightly modified and we started using Napier grass instead of using corn. The advantage is Napier grass, you need not keep sowing every year or every season. So once if you sow, 8 to 9 years we can keep on harvesting. Whereas the maize, if you use as energy crop, every time we will have to redo the things. Then coming to Pressmud, Pressmud is more meaningful for the people who have a sugar factory. For rest of the people, sugar factories are generally controlled by the politicians. So you should know how to handle them. They may or may not respect the agreements. They may not go for the long-term agreement. So just believing on a single sugar factory, if you go for a Pressmud-based CBG, it may become risky. That is the practical aspect of it, not the scientific aspect. And there are two things. These Pressmud sugar factories run for about 6 to 7 months in a year. You should also know what rest of the 6-7 months you will do. And if you do the storage, it will keep losing the gas yield. So older the Pressmud, lesser the gas will come, because the initial formula I have told you, the sugar which is converting into glucose and methane, this methane will get produced in the open air also. You need not in the digester. That's why all this Gazipur landmass has caught a fire yesterday. So that will keep on happening. So this Pressmud, even if we store, there will be a gas emission keep on happening. So the older Pressmud will start giving lesser output. Then there is a rule number 3. Rule number 3 is younger the plant, easy to digest. So if we take a paddy straw, if paddy grows for 4 months, or paddy plant's life cycle is, let us say, 4 months. If you cut at 2 months, the entire paddy plant, you can digest it. Whereas paddy is giving the rice also. When it gives the rice output, plant has finished its growth cycle. When plant finishes its growth cycle, the lignin component, which is the non-digestible or difficult to digest kind of thing, that is highest. So the older the plant, difficult to digest. So that is the thing we have to keep in mind. And good thing about all animal manure, especially of cow and things like that, the bacteria as well as the food are side by side. It is already there in the cow dung. So this will never get into any failure, because bacteria and food, everything is there. So straight away it goes for digestion. So 25 to 30 years also, there are millions of plants which are established based on Deenbandhu scheme are still running, because easiest to digest. But we have a very less yield. It will be 15 kg per ton to 22 kg per ton. So we have to see, in Indian context, it is highly not profitable from cow dung. The reason is the large dairy farms in Europe and US, they have a mechanized way to collect the cow dung and all the waste what they generate. Typically, there will be a moving belt which will keep on scraping the surface. Whatever cow dung is there, that will come out and goes into a channel or equipment. It will get created. It will flow into the digester. There is no manual intervention required. Whereas Indian cow herding or keeping these cows happens typically either in a dairy where manually it is managed, or in Goshala where it is a totally open space. So each lump of cow dung may be falling 10 meters apart. So it is very difficult to collect those kind of things. So we have to keep those in mind. Even though very easy to digest and foolproof, but it may not be very lucrative in terms of gas production and sales. The next comes is the poultry. Poultry litter is a very good ingredient or input for biogas plant. The reason is all these birds have a single stomach, unless like cows. So there is a lot of undigested item. Two things will come. One is the sand will come, that has to be filtered out, and this has a lot of ammonia. So one day you have to keep on mixing in the external air. So whatever nitrogen content is there, that will fly away. Otherwise, it will become overfeeding of nitrogen. Then only it can be fed inside. But your project will be giving out a horrible smell. So that is how the poultry litter works. So you cannot put it very near to the urban dwelling or areas where people are living. They may complain. So poultry litter will horribly smell because of the ammonia. And all this gas generation, whatever people say, this is not at all new. Every ETP, STP plant is producing methane. Most of the cases they are collecting it. In some places it is left to air. But here the concentration on our problem statement is to clean up the water. So people are not caring about emission of the CH4. But there are many ETP, STP, which is effluent treatment and sewage treatment plant, who are having a digester called USAB. So they are producing biogas, and some places they are producing and just burning it off. Here the advantage is raw material is typically free in MSW plant, and if possible, negotiate with the local municipality to give a tipping fee on top of the raw material, some 100-200 rupees per ton. If they give, the whole economics will be working very well. Around 40 kg of CBG per ton you can expect from the gas, as well as you will be getting some 200 rupees from the tipping from the municipality, because you have taken the responsibility of finding a dead end to this municipal waste. And when we say municipal waste, lot of plastic, glass, footwear, umbrella, everything will come. Even the dead dogs will come. So considering all those things, around 60% will be biodigestible. Another 40% we will have to send back to land mass. So that's why tipping fee is very important in MSW projects. Then coming to our own favorite, which is the Napier grass. Here we need not depend on anybody. Depend in the sense, depend on the farmers. We can take land on lease or contract farming basis. Extremely easy to grow, just like sugarcane. It will keep growing for 8-9 years. What we do is, there is a ready sugar and protein in this. This we will anyway digest. Any bacteria can eat away this protein, oil and sugar. Even nobody can stop also this gas generation. So this will automatically happen. So 35 kg of CBG will come because of this. Then we are left with the fibrous part. Fibrous part is also digested using an enzyme. So this we convert it to cellulose, hemicellulose, we convert it to sugar. And once it becomes sugar, the bacteria will take care of making the gas. So that way we are generating 65 kg of methane from 1 ton of Napier grass. And all our projects are basically viable without considering any revenue from the fertilizer. And fertilizer, either you can sell it or you can put it back into the Napier grass. And all this pre-treatment, what we call, there is one more major difference what we have to highlight. Pressmud, cow dung, poultry, the size reduction is already happened. It is already in a very small size. Just you have to add water so that it will become slurry. Paddy, wheat, straw, and Napier, maize, whatever, all this, there should be a grinding stage to make it into a small piece. Add water, then only it can be pumped or biodigested. So there will be additional stage in the agri-biomass project, that is size reduction. So Pressmud to agri-biomass is not one-to-one comparable, because there is one additional stage in this. There are various ways we use enzyme. Apart from that, people boil it, add urea, add acids, steam blasting, ultrasonic. So there are various technologies to break the cellulose and hemicellulose part. Protein, oil, and sugar, anyway, you will get it. You need not worry about it. To break this, we need all these additional processes. And when we do enzyme basis process, you can see that first day it is all chopped grass. By fourth day, it becomes a liquid or sugary slurry. You are pumping, mixing within the digester, moving the slurry here to there, everything will become very easy, just like water. So this was our experimental plant, which here I would say how we got so much of data is there are only two companies did the R&D in India when Satat came in. One is 𝐼𝐼𝐻𝐼, ourselves. Other is Praj. Praj Industries were connected with the sugar industry, so they did a lot of research on Pressmud. Whereas 𝐼𝐼𝐻𝐼 says, we being from Bangalore, we did not have any access to any other raw material, and we did not wanted to go to municipal solid waste. So we came out with, we started studying and finally arrived at Napier. But Napier had no technology available, so we had to develop the technology. You can see square, rectangle, round, all kind of digester we built on a rented place. Then all this purification, we converted our truck, ran for about 10,000 kilometers. Then we also built the purification unit just to understand how it works, so that we can ask right question to purification suppliers. Then even central government minister visited during our R&D days, because government wants to go for a multiple cropping or crop diversification. So that's how we got approved by Satat, Indian Federation of Green Energy, Agarkar Research Institute, Indian Institute of Science, and last month we got approved from Ministry of Renewable Energy, Kapurthala Institute also. So we are going in that route.
Yashuji, where is the plant in Bangalore?
It was an experimental plant. Okay. It was in a agricultural land. So you can see that these are all more or less lagoon type of digesters.
Correct.
So this was not commercial. So, and this was a agri, so there was no possibility to take the PESO license and all. So this we were running for some 3.5 years. In 2022 June, we closed it. And for us, it was very costly to keep it maintaining, just for as a display piece. Then coming to one important thing all of us has to learn, especially the technical guys. There is a gentleman called, was a German gentleman called Buswell. He was American. He was working in something like Pollution Control Board in US. So in the municipal solid waste side, he wanted to understand how much gas will come mathematically. So he has come up with a formula to estimate a methane yield from a feedstock. So this lot of Google search, if you do, you will get this formula. So we will not get into nitty-gritty of the formula, but just remember Buswell formula. So you can really estimate entire gas potential from any feedstock. Now, if you look at, this is the Napier calculation. It is supposed to give 136 kg of CBG from 1 ton of Napier grass. That is 13.6% is supposed to come, whereas we are halfway through, because there will be efficiency losses because of the large size digester. Then next point which we have to cover, whether we can mix multiple feedstocks. The true multiple feedstock is nothing but municipal solid waste. So you get to hear multi-feed digester, multi-feed digester. There is no way multi-feed digester and all will happen. I will just give you example. I am a South Indian. My diet is fixed for rice-based diet. Probably once in a while I can eat roti. Similar way, my North Indian friend's stomach is adjusted to the wheat. Same way, when we shift, if I go to North India and they come to South India, continuously when we start having the food, even within our digester, which is stomach, there will not be conducive environment for those bacteria. So we will end up having acidity. So if somebody is promising or thinking of putting anything and everything into the digester, it is possible, but not like a drastic difference, not the very next day. There will be a gradual increase you have to do, then gradual decrease you have to do, so that the bacteria who are eating those particular substrate will get developed and multiplied. So suddenly we cannot give the shock to this bacteria. These are all single cell organism, even without a mitochondria. I mean, this methane generation happens from a bacteria called archaea. It is not even fully developed bacteria. So any shocks it cannot absorb. It is not a human body even. It is a single cell. So we cannot do. But there is some rules and regulations or the concept you can always think of. Any biodegradation will happen when there is carbon 20, nitrogen 1 molecule, or carbon 30 and nitrogen 1 molecule. This is the range where anaerobic digestion or composting will happen. Then there is phosphate and sulfur also is required, but very, very less in quantity. Like in our human food, in tadka, we put this mustard seed. Mustard seed has a sulfur, so that has a benefit. But we need just 5 molecules of or 1 molecule of sulfur against 750 molecule of carbon. So this we need not worry. We need to worry about C and N ratio. That is 30 carbon should always have a 1 nitrogen. Then only this bacteria skin will get generated. Bacteria every 4 hours it will keep on dying and taking rebirth. Not rebirth, freshly newborns will keep on coming. So to develop this bacteria skin, which we call it as cell membrane, we need carbon and nitrogen. Without this, nothing can happen. Basically, bacteria is nothing but a protein. That's how our COVID-19 people used to do the test. That test is nothing but the type of protein what is getting recognized. So that's how people identify a lot of diseases. So all these bacteria are basically protein. To protein to get formed, carbon and nitrogen proper ratio is required. Now coming to how to manage this 30, there is a simple theory. Now paddy straw is coming somewhere near this oat straw. Okay, this I copy pasted from Google, so there is no paddy. Paddy straw C&N ratio is 80:1. Now 80:1, whereas our conducive environment is 30:1. 80:1 we can feed it, but what will happen? Proper digestion will not happen. We will end up having lot of fertilizer. Lot of fertilizer coming means there is nothing great to feel about it. It means that we are not able to digest it properly. That's why fertilizer is coming. Now to make this 80:1 to 30:1, what you can do? 80 we cannot reduce. Carbon is there already. What we can do is we can increase the nitrogen. So 80:2 if we do, then 40:1 ratio will come. If we do 80:2.5 nitrogen, then 30:1 ratio will come. So all this dry leaf and paddy straw, when we mix with this low C&N ratio items, there are a lot of it. Mainly in Indian context, the poultry waste. Poultry waste and paddy straw, when we mix it, then we'll come to 30:1 C&N ratio. Only when we take care of this, multi-feed digester will work. Then what we have to avoid is all these antibiotics. They will go inside the digester and kill the bacteria. Disinfectant like phenyl or whatever sprays we are doing. And sulfate, sulfide, soluble salts, acids, all those things we have to avoid. A lot of times in poultry manure and also in the cow dung, a lot of antibiotics will come, which are fed to the birds or the cow. So if even with cow dung addition, if no gas improvement is happening, that means a lot of antibiotic is entering into your digester. Right, this is the basic about feedstock, and don't ignore the mixing. These bacteria cannot move around on their own. They cannot swim. They do not have legs and hands and limbs. We have to see that the food reaches to their mouth. So the only way is to mix the tank very well, and at various level different type of bacteria is there. It is mixing means not like making a lassi. So we have to take care of it. So this is about the feedstock. What we'll do, people will go to sleep. So we'll take a round of session questions.
So one question which came up, I think, which is a continuation of what you were discussing. You said we can, use multiple feedstock, but if you are going for Napier or anything, you should do that pre-processing before, right? So how many days more does it take?
No. And see, on average, we have to maintain 30:1. Let us say
the number of days that it takes for the bacteria to digest and release out the gas. Will that increase when you go for Napier or anything like that? Because you will have some days for it to get pre-processed.
And there is no increase or decrease in that sense. Now let us say cow dung will get digested in 18 days.
Right.
Napier and all will get better to keep it for 40 days. But at the same time, 1 ton of cow dung you are getting 15 kg of CBG. Napier you are getting 65 kg of CBG.
Right.
So more sugar or carbohydrate is there, it takes more time for these bacteria to eat and make it 80-20 ratio. We call that as HRT time, hydraulic retention time.
Right.
Thumb rule is all pre-digested, like cow dung, poultry and all 20-22 days.
Right.
Pressmud is like 25 days. Then any agri biomass, better to keep it for 40.
And also, I think I've answered this question, but somebody was asking how much area is required to set up a biogas plant.
So 1 ton about 0.65 acre.
Right. And this is not considering the storage capacity required. Based on whichever region they are going to set up the unit, they will have to maintain how many ever days of storage of raw material.
Yes, sir. See, things like paddy will take a lot of space for storage.
Correct.
Probably more storage space than the plant itself. Whereas in case of Napier, I can give you a precise number. In 5 acre, we can set about 12 tons.
Right.
Including storage. Whereas the Pressmud also need a reasonable storage area.
Right.
Around 6-7 acre.
Slide, you will also talk a little bit on typical capacities and cost of setting up later.
Yes, sir. Yes. That will take it as the second slide thing.
Yep.
Second one, what we'll do, we'll ask your team to share. So because presentation, what I have is a different one.
Okay. I'll just ask my team to share.
Yes. I will have, give me one second. I have it actually. 1 second.
Hey, just putting it.
Yeah, I have it. I will share.
Yeah, we're able to see.
Yeah. So now we'll talk on more on economics, and feedstock part is done. We'll talk about the producing the gas. Since I have spoken on most of this, what you call Napier part and this one, I will skip this.
Right.
And we also talked that this gas production is natural. We can either capture it or leave it. So in nature, the ultimate reality of any biomass getting degraded is becoming a gas. Even human body, when we dig and put it in a soil or bury it, it will finally become a gas only. So this sewage treatment plant we have already discussed. They are releasing the methane or they are collecting. There are probably more than lakhs of plant based on the sewage water. So CBG is nothing new, biogas generation for the industry. Only thing, this Satat initiative is new. That is the thing. And this is very important for all the people who are interested in doing Google-based research. All this Asia, typically we call it CBG, compressed biogas. When you talk in Europe, they call it biomethane. And also about the Napier, there is no Napier in Europe, not that much, because in that region, really what really grows is something called switchgrass. So there are some people who are saying Napier-based plant. Ukraine is there, UK and Austria. There are some plants, but major thing is their switchgrass. And Germany does not have any Napier grass based plant, so you can go and search it. Then next is the South America. They called it bio-CNG. In US region, they call it RNG, which is renewable natural gas. There is one more process which produces methane, which we call it syngas, which is synthetic gas. This is not coming by the biological process, but it is coming from by heating the biomass to 800 degree plus Celsius. Then what happens? Methane will get produced. So that is called pyrolysis, incinerator, whatever the name we call. Basic process has 5 steps. One is we have a biodegradable raw material, which we have already talked, various feedstock. That gets into a covered digester. It can be metal, concrete, FRP, rubber, whatever. Then we are producing raw biogas. Raw biogas has hydrogen sulfide, carbon dioxide, water vapor. There is floating particles, silicon particles, and the methane. So our required gas is methane plus some allowed amount of carbon dioxide, which is 4%. So once this is purified, that gets into compressor, then it is filled into cylinders. The pipeline injection will not happen at 200 to 250 bar. It will happen at around 30 bar compressor you will have. So you can pump it to pipeline. You can sell it to industries and sell it to retail outlets. So for all the enthusiasts and entrepreneurs, my suggestion is see that in your area, out of these 3 sales channels, one is industrial retail sales, automobile retail sales, as well as pipeline injection. Out of these 3 avenues, there should be at least 2 sales avenues, so that you will not get stuck anytime. Don't believe on only one option and rush unless there is lakhs of kg which is getting retailed. So that is the advice.
There is a offtake agreement which we can sign, right?
Yeah, offtake agreement is there. It is like market driven. Let us say now we set up a plant somewhere in what you call center of Madhya Pradesh, where Chambal Valley is there.
Right.
There is no CNG vehicle there. So oil marketing companies, even though they have an agreement, they will not be able to buy and sell it. When there is a market, then only the sales can happen. This we have discussed. This all we have discussed. Now I am coming to digester part. So what are all the type of digester is there? Many people talk, say proudly that dry digestion. There is nothing called dry digestion at all. Any biodigestion needs water. No cow can be fed paddy straw and without water. So it has to drink water also.
Right.
So dry digestion is, meaning is there is 15% plus solid. 85% water is still there. When 15% plus solid is there, we call it dry digestion. When 15% and less solid is there, it is called wet digestion. So dry means it is not like them creating gas out of a powder. Water mixing is there. Then construction material basis also we can do. There is concrete. It can be 20-25 years also, you can easily target the life. Steel, typically people say 10 years. Then there is flexible sheets. These are all slightly for what you call no immediate purpose or low cost purpose, or just biogas to electricity kind of purpose. So flexible sheet is the DPE sheet, and many types of materials will come. Next is the FRP. FRP, the problem is it's a good one, is it's not environmentally friendly, because once you discard, maybe probably millions of years it is going to be there telling our story of biogas plant. Secondly, if there is a crack, and that will happen, if you drop a hammer, it will generate a crack and hole. There is no way to effectively plug that damages in the FRP. It is like one-time build kind of thing. Then placement of the digester, it is nothing specific. Above the ground, below the ground can happen. This basically is decided based on the soil's weight bearing capacity in your area. At what depth the foundation thickness will be thinnest. Based on that, it is better to go for above and below. Some things like Pressmud will carry a lot of mud, so it is better to have it above the ground, so that after 3-4 years, when the time comes to clean, it becomes easy. Whereas Napier and agri biomass and all can go below the ground, because there is not much soil content will come. It is better to go for above the ground, even for the poultry, because a lot of sand will come. Then next is fixed dome and floating dome. All this balloon kind of thing what we are seeing, that is the fixed dome. So dome is not moving, it stays there. Floating dome is all this KVIC kind of model, where there is a vertical vessel kind of thing, or a lid kind of thing, which will keep on moving up and down based on the gas produced. In the household plant, the advantage is this floating dome will have a particular weight. Whatever is the quantity of the gas, because of the weight of this dome, the pressure will be constant towards the burner. So if you are trying to make a tea with less gas also, or the higher gas, whatever the day is, still the flame will come equally. That is the advantage. This is not suitable for very large plants, and it has lot of leakages also, means methane leakage. Then agitation, which is the mixing of the slurry, can happen inside the digester or outside the digester. We prefer outside because maintenance will be easy. Whatever the machinery moving part within the digester, because of the acidic environment, eventually they will fail. Eventually 2.5-3 years they will fail. It needs a replacement. So the moment we open the digester, the anaerobic condition, which is the absence of oxygen, that condition will go away, and we need another 1.5-2 months to create that oxygen free environment within the digester. So we should aim that no circumstances there should be a need to open the digester. That should be our design. And based on the working principle, there are digester, continuously stirred tank reactor, CSTR. This is the most famous and most used, especially in CBG sector. Plug flow is something like a snake. So if you put from the mouth, there is no way that the first day's material will come out the next day. Whereas in continuous stirred, some amount of material can come out very next day also. Without crossing 40 days or 20 days HRT, it can come out. Whereas in plug flow, it is like a cow's not cow, it's like a snake's stomach. So whatever we feed in, it will compulsorily come out after the number of HRT days is crossed. Batch process is suitable for municipal solid. Rooms are constructed, waste is dumped without even segregation, door is locked, whatever gas comes out. Then after 40-45 days, the room is opened up, that digested fertilizer is taken out. So that is the batch digester. Next is upflow UASB. This is highly used in municipal waste water treatment tank. Here what happens? Undigested solid can never come out. It will keep falling inside. So what comes out will be only liquid part. That is the way it works. Then in the digester, based on the temperature, we segregate 3 categories. One is the thermophilic, which is 53 to 55 degrees maintained typically. For the very high protein, very high oil, very high grease kind of material, this is better. And this is extremely difficult to maintain it because these bacteria are not occurring in our region. Let us say if we are setting up in Bangalore, Hyderabad, Lucknow, wherever, there is no thermophilic bacteria abundantly available. These bacteria are actually thriving in the hot springs. So that is from where we have to come. So the moment it drops like 53 degree, we have to maintain. If it becomes 50, 49 because of any reason, we will have to redo the whole thing. So that is the challenge with this kind of digester. So these bacteria are like, one of my technology friend was telling, it is like maintaining an angry wife. So that is the summary of it. Then we have a mesophilic range. Simple thing is our human body temperature. So we ourselves are made from bacteria, algae, chimpanzees, everything. So we are the resultant of all those people. So bacteria's required temperature and our required temperature is not different, is 37.4, 37.5. So 32 to 42 kind of range. This is what is the mesophilic range. Then there is psychrophilic. Below that is like 20 to 30 degree kind of range. Below that it becomes a refrigerator. So no biodegradation, nothing will happen. So if we put the biodigestible material, make it a 4 degree, 5 degree temperature digester, go home and come after 10 years, it will remain same. That is the thing. And there is one big, what you call now, we are all fancy jargon kind of people. So you will come across people who are telling hydrolysis, acidogenesis, all big words. So this big word, let us try to simplify and understand. Hydrolysis is, now suppose we mix wheat, atta and water, forget to make it chapati and leave it for 2 days. Some amount of watery kind of things will start. So hydrolysis is nothing but that. So there the water is getting generated and all these long chain polymers are slowly getting degraded to simple edible component for the bacteria. Next what happens, this will become sour. Sour in the sense we cannot compare it to our curd becoming sour, but we can compare to the same chapati atta which is becoming sour after 2 days. If we chew, it will be sour taste. There what has happened, it has become various acids. So acid is typically sour. Here lactic acid predominantly will happen. So that's why it is showing the taste of sour. So the moment it crosses, none of this material what we fed is no more Pressmud, it is no more Napier, it is no more municipal solid waste. It is just the mixture of acids. It is a biochemical. That's all we can call. We cannot further call it like Pressmud. So once this becomes an acid, there are two ways. At this point, if we introduce the fungus, it will become ethanol. That is how the wine and liquor gets produced. The other way is introducing the bacteria, then the gas will get produced. So here there are two pathways. One is it will get fermented through H2CO2. The other side it becomes a acetic acid, which is vinegar. So soon after acidogenesis, some hydrogen will get produced and carbon dioxide also get produced. Otherwise, it will become acetic acid. We cannot control how much will happen, how much. It is decided by the bacteria. Then this acetic acid is eaten by the methane generation bacteria. In that there are two. One is H2. They will eat these CO2 and H2 and make a methane. The other type of bacteria, they eat the vinegar and make it the methane. So both together it will become CH4 plus CO2, which is nothing but biogas. So this is how it is. So hydrolysis becoming acid, becoming vinegar, becoming gas. That simple it is. Now this gentleman we have already spoken in the last slide. Now I'll jump on to purification. Purification, there are two aspects as we have initially talked. There is moisture, there is a particles floating around like dust, then there is a hydrogen sulfide. That has to be removed, which typically the purification suppliers or the technology providers call it as gas preparation step. The biomass preparation is different. That is the chopping, grinding. So biomass preparation is different one. And when purification companies talk about the preparation of the gas, they are talking about removing the H2S, moisture, and the particles. Once that is done, the next is we have to separate the methane as well as the carbon dioxide. So CH4, CO2 getting produced. We have to separate those two things out. Just like in hospital oxygen generator, nitrogen and oxygen is getting separated. Similar way, we have to split this. The methodologies are not very high. One is the water scrubbing, where just like we produce soda contains the CO2. The similar way, methane or biogas is brought in contact with water. Then water will absorb the carbon dioxide. It will not absorb the methane. So this becomes water becomes soda, and in the next stage it will bubble down and it will release the carbon dioxide. It will come back to this tower. So this is water scrubbing. This can happen with pressure, without pressure, atmospheric pressure, at a low temperature, high temperature. So many things can happen. Next is the exact same thing. Instead of water, we are using a chemical like amine. So amine or sodium hydroxide, those kind of things, when you use it, the water can absorb, let us say 2%. When you put this fellow will start absorbing 20%. So that is the advantage. And here also, once this absorbed, this has to be regenerated. Whereas if this is happening at room temperature, it has taken in the carbon dioxide, has dissolved in the chemical. It has to go to next stage, and there we have to boil it to bring out the carbon dioxide and recirculate, keep on recirculating. So operational expenditure will be high because we have to, every time we have to cool this liquid down and boil it again. Next is the most famous pressure swing absorption, vacuum pressure swing, and temperature swing. All these 3-4 things are same. In your laptop bag, if there is a small packet of that desiccant packet is there, or even in nowadays little costlier chips packet, we can see that desiccant dryer silicone thing is put. The similar material will be there in the tower that will selectively absorb the carbon dioxide. It will not absorb the CO2, methane. So it will, it's just like a sponge absorbing the water. So whenever there is CO2 molecule comes, it will just catch it. It will not catch the methane molecule. So from the top, only methane will come out. At one point of time, because of absorption, the whole bed or the chemical in this will become saturated. Just like sponge ends up holding the water, no? There is a limit. Then vacuum pump is switched on, and vacuum pump will suck out those absorbed carbon dioxide. So this will become fresh. While this is becoming fresh, the other tower is producing the methane. So alternatively, this one keep on switching. That's why we call pressure swing absorption. So swinging between two towers. It can be multiple tower. It can be 9, 12, anything. Temperature swing is same. Instead of pressure, it is heated and cooled down, heated and cooled down. And membrane separation is the same material, made it in a form, just it looks like a noodles. And it's a tiny pipe. So what happens, one side, if you put the biogas, the other side carbon dioxide will come out. Here other side methane will come out, and from the walls of these tubes, carbon dioxide will come out. So that is how it does the filter membrane. Next is the cryogenic. Cryogenic is carbon dioxide will get liquid at -30, -60 kind of temperature. Whereas the methane will get liquid only at -169, 171 kind of temperature. So if you bring this biogas
to capture this carbon dioxide?
Yes, sir. In all of this, we can capture it. Except for water scrubbing, rest of the things it is captured. In cryogenic, what happens? We are liquefying the carbon dioxide, means -60 kind of temperature is done for the gas. Carbon dioxide will automatically become semi-solid or fully solid. We call it dry ice. And whatever gas left out is methane. So people get very high kind of purity. But right now, there are only few European suppliers who make this. There is complexity involved in the mechanical aspect. Cooling and all is very easy. 25,000 meter cube plus kind of projects only. This is right now viable. We are trying to miniaturize this. We are working, but it will take some R&D fund and all. So these are the various methodologies we have for purification. So this is the photo of the molecular sieve. You can see that this is a very high 500 micron kind of this one. Methane molecule cannot enter into these pores because it is bigger, whereas carbon molecule is smaller. CO2, there are only 3 things. CH4, there are 5 things. So it is a big laddu kind of thing. So that laddu cannot get into these pores, whereas the smaller CO2 molecules will get into this pores. So that is the way it works. Cost-wise, probably the low cost is the general atmosphere-based water scrubbing. But here, based on the temperature variance, your purity also will keep on going up and down. Next comes this the chemical scrubbing as well as pressurized water scrubbing. These people will be always in what you call cost-wise competition. Then next we have is the PSA and VPSA kind of technology. Then we have is the membrane. Then we have cryogenic. So this is the cost-wise. These numbers is just an indicative for let us say for a project. 40 lakh is the general atmosphere-based water scrubbing. For a similar project, it will cost 80. For a similar project, it costs 120. That way, I'm showing. Then coming to compression. Compression, we have 2 technologies available. One is the compression which is happening probably in our puncture shops, in our car tire, what we are filling. That is a mechanical compressor, and the reciprocating piston will be there that will keep on compressing the gas. It uses quite a lot of energy because there is a lot of heat loss will be there in this because of the reciprocating movement. The second type of this is the things which is like a bulldozer, where hydraulic oil is pressurized and that is moving the piston. So whenever there is a piston movement, there is no it will transfer the energy to the gas, but whatever is left over it comes back to the oil. Whereas in reciprocating, what happens, if there is a gas, no gas, the moment a stroke happens, it goes forward and comes reverse. One cycle is complete. Again, to go forward, it needs full energy. Whereas here there is lesser loss of energy in hydraulic. But there are some constraint in hydraulic. It cannot take from atmosphere bar. We have to raise it to some 40, 50 bar pressure. Then only it can take it further. But the power consumption is very low. Combination of these two, when we do, then we will have the advantage of lower OPEX. And because it is all oil moving kind of thing, the wear and tear is low. All our HPCL, BPCL, IOCL, whatever CNG outlets you are seeing, mostly the booster compressor is off hydraulic. Very few cases there will be mechanical. Then coming to the distribution, it cannot be distributed in household kind of cylinders. Household cylinder working pressure is 2 bar. It is built for about 13 bar. The moment it crosses 13 bar, you can expect a what is that, Rameshwaram cafe. Then we have a forged cylinder, which is a completely a single piece of steel until this neck, and beyond this also there is no welded joint in this. This is the cylinder we are supposed to use, and this is the kind of cascade used for transportation. Also, we can make bio LNG, that is by reducing the temperature. This is for hotel supplies. You can also make 1 number, 4 number. Many people have a misconception that cascade means 40 cylinder. There is nothing like that. You can make even 100 cylinder cascade or 2 cylinder cascade. Then next is the pipeline. This is how the distribution happens. Then what other industries we have for CBG other than oil is Satat marketing based. Electricity generators can take the CBG. Ovens, canteens, confectionery, biscuit manufacturing, metal melting over all our casting companies, powder and paint drying industries, powder coating, heat treatment, especially the tempering process, paper corrugation where they have to keep the adhesive in the liquid form, so there is a continuous heat, and all this water tank manufacturing, which we call it rotomolding. So these are all the various industries apart from automobile which we can approach. Also we can do is the existing burner and engines can be converted to CBG or CNG, or it can also be doing dual fuel, means either it will run on diesel or run on CBG. So that also is possible. So there are unlimited opportunities in sales. So I will take 1 more minute, people who are really getting into the project. Before all this, I was with a very large EPC company, that was with L&T. So what we learned during those days is CBG or any large project, first we have to think of investment justification. Why at all I'm getting into this? To make more money, increase my wealth, or reducing the cost of energy within a factory. So there can be multiple reasons, investment justification. So once that is done, then you have to go for a comprehensive RFQ. If you just say like 3 TPD plant I want to set up, it will become a very easy for the external people or consultants to misguide you. So as far as possible, you derive the proper problem statement. This is what, this is what, this is what. Or you can always take a hire the consulting, because whatever money here you are spending, that will ultimately save in lakhs here. Few thousands you may be spending here. Then once that is done, you have SolutionBuggy and many options available. You scrutinize the what you call replies based on technical and commercial capability. You select a supplier or technology provider for you. Then a good technically capable technology provider can always match your expected cost bracket. Whereas if you go for a cheaper solution, they may not be able to bring up with the creative solution to bring up the project cost. So it is always better to go with somebody which is having a merit on the knowledge side. If there is some 50 lakh here and there, whatever project cost has to be adjusted or reduced down, a technically capable supplier can always help you do that rather than the commercial side. Once that is done, together you are going to do the design. At this point, the team got created. There is a technology provider, there is a customer. Together you go for a design. So what happens? About 20% of the cost you can save by interacting closely during the design phase. Whatever negotiation, hitting the supplier, locking in down, it may save only 2 to 3% of the costs, nothing more than that. So better, all the savings will come from a good design. Then you make a list of spares and consumable. Then your supplier will build your plant, give the training, make an SOP, which is standard operating procedure, take the maintenance manual, then you give an exit to the technology provider. So if you go by this methodology, nothing will go wrong. Even something is going wrong, it will get readjusted. Raw material, avoid the dependency and all these things. I think we have talked most of this. Agitation of the digester, we have already spoken. There is a propeller based agitation one way, the other is jet based agitation. So liquid jets are created and they will mix the pump. The other way is putting like a fan kind of structure inside the digester. So based on the raw material thickness of the slurry, that will get selected. So these are the few of the things which are a safety thing, but we need not cover today. But since I have shown you the slide, I will tell you. Not every thread in the oil and gas sector is same. So that mating can happen between the particular kind of thread only, even though for normal eyes it may look similar. So these are the small things which will be safety critical, which you will have to follow. So this is especially I'm telling for the do-it-yourself mode of entrepreneurs who are trying to source their own component and build it. Then there is something called SCADA. You should be able to see all the operation even if you are on holiday or traveling wherever it is. So that is very important. Your SCADA is not a touch screen which is sitting within the plant on your electrical panel board. SCADA means it is supervisory and data acquisition. Acquiring you to see or location. That is important. Sir, to the question, I think probably the part Guruji Gururaj has highlighted.
Right. So
take a question for getting into it.
I will just You will give an idea of the investment and then I can ask the question, right?
Right, sir. I have made a very simple sheet instead of getting into too much nitty-gritties of projected financial depreciation, that is thing. What we'll do, I will take an example of like 3 tons. So 3 ton typical cost of plant and machinery. Generally, as a thumb rule, as of now, you take it as 5 crore is 1 ton output. So based on that, some 15 crore will be our capital. And in this, there will be some amount which will be GST, which will be coming back to you. So all those things. But as on today, there is will be outflow for plant and machinery. For this, 30% is the expectation of the bank for the margin money. Then capital loan about 10.5 crore we will be taking. Then working capital you need. Then there is a subsidy component which is 83 lakh rupee per ton of output. So whatever size you build, 83 lakh is this. Now I have a sample for grass.
And also, Shashiji, the SATAT scheme is applicable only for about 2 TPD.
Yeah, below 2 TPD, this is not at all viable. Means making it automobile grade fuel, it's not viable. My advice is strive for 3 TPD. Means even if you have to take one more partner or equity investor, start with 3. 2 TPD is highly, because your fixed cost will remain same. Office building, transformer, lighting, compound wall, everything will remain same even for the small plant or big plant, including statutory approvals. So better to go with 3 TPD. Right, then we have grass. I have taken around 500 rupees for the grass. It is coming to 670.
And in this model, you are assuming that you are going to buy the Napier grass from the local farmer.
No, lease land.
Correct.
I'm taking the land on lease, probably at 20,000. That is the number almost across India. So growing Napier, it will cost only 422 rupees, including transportation. So it is much viable. So we will just see it is the raw material cost. Manpower 3 TPD, you need around 8 people in 2 shifts. Electricity, simple thumb rule is 1 kg CBG is equal to 1 unit of electricity. Then maintenance 1.5% of the capital cost you have to keep aside. First 1 or 2 years you may not need this money, but eventually it is a process industry. So things will get wear and tear will be there, it will go wrong. So we have to keep that corpus aside. The depreciation you are keeping aside, that is for a different purpose. So here I am talking about the maintenance cost. Then consumables and monitoring, if at all you are using something like enzyme or some chemical kind of thing, or if you are putting directly cow dung or poultry, this can become only like 1 rupee per kg kind of thing. Then we have transportation, 1 rupee 50 paisa typical transportation per kg of gas up to 40 kilometers. And every day it is better to clear off the fertilizer instead of keeping in the within the plant premise. So that also will cost about 4,500 fertilizer transportation. Even if you stock
right
it
now,
today or
there
tomorrow.
Is some government scheme, no, for fertilizer, 1 rupee or something they are giving.
Yeah, 1 ton 1,500 rupees you will get it. That is 1.5 rupees per kg. This is the fertilizer transport. So altogether, our daily cost is 81K. When we divide this 81,000 by this 3,000 kg per kg, our production cost is coming to 27 using Napier on a leased land basis. Now what I will do, I will just take this out. I will make it like 1,000 rupees landed based on the contract price. Then your cost of production is going to around 36 rupees. So this is where we are. Then we have oil marketing company. Minimum 54 is the base price you will get, floor price. Below that, this will not go. The retail price or the OMC buying price from you is linked to retail. Linked to retail in the sense they have made slabs. If there is, I will just show you. Right now in the outside market, typically all across India, the sales price is 88. So CBG producer will get 66 rupees 67 paisa plus GST. That is what they will get. When it becomes 89 also, it will remain same. When it becomes 90, this will jump up by 4. So every 5 rupee jump, you can see that there will be 4 rupee jump in the buying price. So that is how it is. Around 78% of the retail price will be OEM's buying price, you can say. External sales, I am saying at 85. So now income from sales of gas is coming, this 66 rupees 67 paisa. We have 3000 kg every day, 365 days of running at 90% efficiency. So just by selling the gas, we are having a 6.5 crore of revenue. So 3 TPD, 6.5 crore. So 1 is to double. So that is the way we can easily remember it. Then fertilizer income, I am showing at 0 in this, but we'll add is there is a 1500 per ton, which is market development fund. They will be paying you for first 3 years. So that is fetching about 30 lakh. And if we properly brand it and promote it, it can go up to 7-8 rupees per kg also. This is the bare minimum I am taking. Liquid fertilizer, typically there will not be any market. So in Napier case, it goes back to Napier field, or else you will have to give free of cost to some people. There are companies who are able to brand it, but it took some 5 to 6 years for them to make their brand. So there will be significant investment on supply chain, stockage, super stockist, wholesaler, retailer, everything will have to be set up. This carbon dioxide can be liquefied and sold, which will have additional 2 crore of investment, because you have to invest in carbon dioxide cylinders as well as making it a liquid. So this 15 will go to 17 odd. But carbon dioxide, it depends area to area. Some 8 rupee is the general. If you do, you will have some about 88 lakh of revenue. But observe that here there is no additional OPEX involved, some 2-3 rupees to liquefy it, because rest of the things in PSA we have done already. So not to misguide you, I will still keep it 0.
But that also depends on if we have a bottling unit close by.
Bottling unit, and there should be food industries, and CO2 welding should be happening. So it's not there is no market all across India. So coming to all this, we have this is our revenue. Then we have daily cost, which is 2719 multiplied by 3000. And this cost I have not multiplied with 90% efficiency. I have taken 100% only. Every day there is a cost. That is the assumption. So this is our gross profit, 393 or 4 crore. So for the investors who are evaluating, what is happening by putting 1 crore rupees or 1 lakh rupee investment, we are getting 25,000 rupees as the yield. So in this, even if you pay 11% to bank, we are still left with 13% in pocket. So that is the workout in the CBG. And whatever payback is 21 month. Here I have to tell you something. A lot of people get misguided with the ROI calculation, especially who are first generation entrepreneurs. So now here we are putting 466. This is our margin, right? 466 our margin. When people talk about ROI, they want to get back this 15 crore. So 15 crore, they want to invest 4.6 and make the 15 crore entirely theirs. That is the meaning of ROI. So for this to happen, you want 3.2x of growth. So that is 320% of yield on your investment. So 466 you invested, you want to have a 320% yield, means who want shorter ROI, those people I'm reminding, 320% kind of money will never come back in any legal means of earning. So it will take 5 to 6 years of ROI if you are targeting 15. Right? So 1 year ROI I want to have, 2 year ROI we want to have. That is not going to happen. Here, the game is very simple. This 15 crore can means it may remain as a property of the bank, probably for next 100 years. It is just like we are living in a rented house. We are paying the rest. We are what we should be doing is we are holding or maintaining this asset of your even hours generating me 4 crore of gross. This is what is our gain by making those machines as 100 hours into earn anything. Okay, and that is depreciation asset. That the love towards machine we should leave, then only we will be able to multiply your business venture. Concentrate on the cash flow. The long sentence, so about it. Coming to the same 3 TPD, there are 2 ways to look at it. One is by investing 1 lakh, I am getting 25,000 rupees. The other way is looking at the break-even point, what is happening. Depreciation, interest and manpower, it is a fixed cost. Even if you do not produce even 1 kg, this will have to be paid. Manpower, ultimately on someday you can plan kicking them out, but still it is a fixed cost for. Then all these raw material, consumable, everything is your variable cost. So if there is no production, this is not going to, this cost is not going to come. So this is a formula, break-even point. When you do that, what it is showing is from our 3000 kg project, if we are able to sell 1870 kg, all our fixed cost will get recovered. 1871 to 3000, whatever the 1200 kg is there, that is our profit. So this is the other way of looking at the risk reward ratio.
Okay, sir.
Yes, sir. My planned is done.
Right. So I'll just share a poll for all the people who is looking at their screen. Kindly answer this question. Meanwhile, I have one person who wants to ask a question to Prithvi. I'll just allow him to ask one question. The others, can you please answer the poll question, please? It is coming up on your screen. I have Mr. Pratap Narayan who has a question. Mr. Pratap, please ask your question. Mr. Pratap, are you able to hear? No to talk. Mr. Pratap, are you able to hear us? You have a question. Yeah. Sir, I'm not sure if he is available. But one question which we also keep coming across from entrepreneurs is, doing Napier grass is good, but what is the guarantee that I will be able to source the Napier grass from the farmer at whatever rate which we have agreed? So if tomorrow there is a plant coming up in the vicinity, then there is, they might start supplying to him as well.
Of course, they will start. That is what has happened in Thailand. Wherever they get a better price, they will get it. But our ROI period is about 3.5 years. So we should be 3.5 year kind of holding we should be able to have. That is one part of the story. Second is, for no entrepreneurs, I suggest 100% contract farming based. That's why I always say lease based or lease plus contract farming based. There should be some 50% which should be on lease on the company side, which is in 100% control.
Okay, so it is a mixture of both contract and lease. So some of it
Better to see if you do it on lease basis, it is much more cheaper also, and you have full control. And also there are plenty of land which is available. Actually, if you look at the urban migration numbers, probably most of us are from villages who have switched to various entrepreneurship or corporate job.
Right.
So just like that, there are millions of people switched over, and there is a lot of uncultivated land lying in the villages.
Right.
So that is the business decision, sir. So in whole of this business, there will be loopholes, there will be failures. If you contract with 20 farmers, 2 may walk over, but overall,
Right.
the world is better. There are good guys are more than the bad guys. That's all I can say.
How much time will it take to commission a plant?
Typically, what I am seeing is 7 months for bank financial closure.
Okay.
Then there will be 2 months. Within that 7 months, 2 months will be because of the statutory approvals and all those things. Then it will be the real establishment installation time will be maximum 8 months.
Right.
Here, entrepreneur has to start the activity only after proper financial closure. Halfway in between, nothing should be started. Otherwise, they will get stuck.
Right. Okay. And
yeah.
Can you give a little bit, very briefly, what the 𝐒𝐡𝐻 scheme allows?
In 2019, 18-19, the 𝐒𝐻𝐻 got launched. The basic fundamental, because we were part of this whole thing since beginning. There was a lot of push happening on ethanol, but ethanol entry point was hundreds of crores.
Correct.
So some of the ministers in the central government wanted to have some kind of energy for the general people at a lower bracket of investment.
Right.
So this 𝐒𝐻𝐻 got formed, and in 𝐒𝐻𝐻, the mandate is, the initial mandate was oil marketing companies, HPCL, Indian Oil, BPCL, GAIL. They will buy the CBG if the local entrepreneurs buy it on a 10-year or 15-year long-term contract. So in this contract, 15 years or 10 years is a choice which is fixed. The pricing is fixed. Quantity is slightly left loose. Slightly left loose in the sense there is a wording saying that if there is a sales or until the sales gets ramped up, it has to be a combined activity. That is the wording they have used. That is fair enough. The reason is no company would enter into 15-year into price into quantity guarantee also. Then it becomes a open check or it is a bond. People can even sell that agreement itself and make money if all three things are promised. So there is a quantity which is kept as a star mark. Otherwise, if the location is right, if there is CNG of sales is happening, number of cars are there, industry is available. This 3 TPD, 10 TPD and all is a very small quantity in CBG. We have 3 lakh ton of daily consumption of CNG sitting today. And we are talking about 3x increase. So this is Satat is nothing but that. Local entrepreneur, from local entrepreneurs, the gas will be taken, retailing will be done by oil marketing companies. Afterwards, it got attached with pipeline injection came, then even the private companies have to blend this 5%. So all those obligations were later added. Even today, we keep on suggesting and doing some lobbying with the government to keep on improving it, incentivize. Like now, agri biomass collection machinery, there is a 50% subsidy. So all those things are getting added one by one based on the industry requirement.
Right. Okay.
In the chat box, I am seeing quite a lot of questions. Some of them I tried to reply by the chat itself. You can just scan through so that you can.
So regarding location, we can set up nearby any metropolitan city as sales channel and
yeah, metropolitan. See, think of next 20 years. It should not happen that after 5 years, your project is in the main circle of the city center. So it is better to go a little beyond.
Right. Because it emits a lot of smell. There will be
no, smell will not come. Smell, especially Napier will not give the smell, but all this Pressmud, municipal solid, and poultry will give a lot of smell. That smell will not come during the digestion, but in the transportation, when you from truck to pre-mixing tank, when you are transferring, that time smell will come. Inside the digester, it is fully covered. Nothing will come out.
I have one Mr. Mahesh who wants to ask the question. Mahesh, yes. Are you there? Mr. Mahesh, you have raised your hand to ask the question. Are you there? Mr. Mahesh? Okay. So anyway, the next question is, do we have any MSME or PGME help in these projects? Yeah, anyway, there is the Satat scheme and MSME schemes are also
applicable. Sir, that 20% due with the DIC scheme.
Right.
In whichever state it is applicable, that is available to any MSMEs, not specific to biogas. That is available to everybody.
Right. How many months it will take? Okay, that we have asked. Provide the percentage. One more thing is, can we set up a plant in a dairy farm of minimum 50 to 100 cattle?
Each cattle will gift us the cow dung of 14 kg. So 14 kg into 50 is how much? 700 kg. I don't think it make much sense, but what you can do is you can make a simple biogas plant.
Not compressed biogas.
Not compressed biogas plant.
As Pressmud is available only for 6 to 8 months, how can we use other feedstock? Yeah, that is, sir has answered. Shashi sir has answered that. We can't directly change the feedstock abruptly. It has to be done over a period of time. I think, sir, we have answered most of the questions.
Yes, sir.
Yeah. So I think it has been a wonderful session with Shashi ji. More than sharing the knowledge, it was more like telling the facts through stories. So it is something that anybody and everybody can understand and easily comprehend. Of course, 90 minutes is not enough to answer such a vast subject, and especially a subject which has been has come up very recently, And more than knowledge, I think a lot of rumors are floating around. So that has been put to rest, and with a very practical approach, and showing all the calculations also in front of you. So please do not get mesmerized by whatever lucrative offers and things that are floating around. Make sure that you are putting in your efforts and making the calculations yourself, and then get into this. For any kind of assistance, of course, SolutionBuggy and Satish sir are there. So do get back in touch with us. Thank you for being a wonderful audience, and thank you, Chetty, for explaining all the concepts and taking your time off your busy schedule. And over the last 90 minutes, it has been a wonderful session in helping us understand the entire world of PDP. Thank you, sir.
Yeah, thanks a lot, sir. Keep this going, and through your network and guidance. And also, I see a lot of people trying to do it yourself mode. So
Right.
even those people should approach SolutionBuggy to select the right machineries. The reason why I'm telling is, even Icons was approached, and SolutionBuggy visited our office and verified that we practice
Right.
in the market. So you get advantage. So buying some machinery, those kind of, better to go through. Not recommend with this platform, but definitely not Trade India kind of people.
Right.
You college person. So go with stick platform. Yeah, thanks a lot.
Thank you. Thank you, sir. Thank you for the time.